Good morning, everyone. So last time we spoke about how we could solve a system of equations by graphing. Today we're going to talk about how to solve a system of equations without graphing. Our first example is in orange, which, as you know, means you don't need to write this first one down. So let's say we've got these two equations in front of us. Y equals 2x plus 1 and y equals 3x minus 1. Well, the first thing that I need to do is I actually need to set these equal to each other. Remember, when we solve for a system of equations, we want to find a coordinate point, which means an x value and a y value. And we want to find the coordinate point where these two graphs both have the same x value and y value. So I'm going to start by setting these equal to each other. I'm going to say we can agree that y equals y, can't we? And since we're looking for the place where they have the same x value and the same y value, we know those y values will be equal to each other, so we can say y equals y. Well, because we can say y equals y, we can say this y is going to equal 2x plus 1, and this other y is going to equal 3x minus 1. So now I'm going to say 2x plus 1 is equal to 3x minus 1. So the first thing I'm going to do is, since I don't want to have to work with any negatives, so I don't want to say minus 3x over here because that would give me a negative x. I'm going to subtract 2x from both sides. And that leaves me with 1 equals, those 2x's cancel, and 3x minus 2x is just x, or 1x theoretically, but we never write the 1, minus 1. Now I'm just going to add 1 to both sides to get x by itself. I won't even have to divide. Sorry, these are the fancy ones that have the bottom and the little nose-shaped top. And I'll get 2 equals x. Now the truth is, I've done most of the work that I need to, but I've only got half my answer. Because remember, what I want to have is an x value and a y value of the point where these two lines cross each other. Now, I almost certainly have my x value. This is half of my answer right here. But I'm going to plug this in to whichever one of these I think is easier. So I'm going to say y equals 2x plus 1. I'm going to substitute. We'll learn an exact definition of that word a little bit later. I'm going to substitute 2 for x. So I'm going to say y equals 2 times 2 plus 1 equals 4 plus 1 equals 5. Okay, so now I've got y equals 5. And if I'm taking a test and I've got one more question and 30 seconds left, then I'm going to be putting this into coordinate point form and just be done with it. That being said, let's say this is the last question and I've got 2 minutes left. There's one additional step. I'm also going to plug that x value I found into this other equation and make sure they come out the same. If they come out the same, terrific. I am all good and done. So the other one is y equals 3 times x, which we're going to say is 2, minus 1. That comes out to 6 minus 1, and that is 5. Hey, terrific, they came out the same. I know my answer is coordinate point 2, comma, 5. And I'm there. So now let's formalize this. Let's look at the big ideas behind it. Do that, we're going to need one vocab term, and this is in black now, so do write this down. Our vocab term is substitute. This means to replace a letter with a number. So what I did up here, where I replaced this x with that 2 that I found that x equals, that's called substitution. Now make sure you get these. Steps to solving a system of equations without graphing. 1. Isolate the same variable in both equations. Usually it's going to be y that we isolate first because that puts it into slope-intercept form, which we're fairly comfortable with. 2. Set the equations equal to each other. 3. Solve for your first variable, which is usually x. 4. Substitute the value that you found for the first variable into one of the equations to find the other variable. 5. Give your answer in coordinate point form, meaning x value, comma, y value, and in parentheses. Now, step 6 is when you have time. So step 6 is time allowing. Repeat step 4 on the second equation to make sure your values come out the same. If the values are different, you might need to start over. So let's look at 2 more examples of these, and this time it's going to be in black, which means we do need to write it down. Alright, so let's say instead we've got y equals 5x and y equals 4x plus 1. In this one, the first step has already been done for me because it says isolate the same variable in both equations. Well, these are in slope-intercept form, which means the y's are already isolated. The y's are already by themselves. So I can just sort of skip to step 2 where I set them equal to each other and say 5x equals 4x minus 1 plus 1. I'm going to subtract 4x from both sides. And I will get just x equals 1. And now because this top one is easier, I'm going to say y equals 5 times 1 so that's 5 and y equals 5 there. Now I'm going to do step 6 really quickly here. Okay, so just checking on the second one too. 4 times 1 is 4, plus 1 is 5. Oh hey, y equals 5 on this one too. They came out the same. My final answer for where these two graphs are going to come together on the same spot is 1, comma, 5. Have any doubts about this? And you go, I don't know, is that really the point where they come together on a graph? Well, here are these two equations on a graph. You see that gray dot right there? That's where they come together. 1, 5. I know you have to sort of zoom in to see that that's where they come together. but it is. So let's do one more. This one will not be in slope-intercept form, so we're going to have a little extra work to do. Let's say for this one, we need to solve for this system of equations, and we've got 2x plus 2y equals 8. And we've also got 6x minus 3y equals negative 3. Now, with these, what's this form called again? Where we have x's and y's on the same side and just a plain old number on the other? Oh yes, it's called standard form. So these ones are in standard form. Officially speaking, if you want to, you can put it in terms of x equals something y plus a number. That being said, I think it's easier just to think of it as you always want to put it in slope-intercept form. The book is going to say, okay, put it in terms of the least positive number. So if we had 3x plus 6y, you'd want to put it in terms of x, according to the book. Like I said, I think it's easier just to think of it in terms of putting it in slope-intercept form, because that's the one that we're most familiar with. So let's look at this first one for our first part here. All right, to put this in terms of y, let's subtract 2x from both sides. And then we've got 2y equals negative 2x plus 8. Now I'm going to divide everything by 2 because 2 is multiplying the y right now. Then I get y equals negative x plus 4. Y equals negative x plus 4. There we are. Now for this other one, I'm going to subtract 6x from both sides because I want the y by itself. And that leaves me with negative 3y equals negative 6x minus 3. Now I'm going to divide everything by negative 3 to get rid of that negative 3 that's multiplying the y. Alright, so that leaves me with these negative 3's cancel. Y equals negative over negative equals positive. That's positive 2x plus 1. Now, I'm ready for the step where I set them equal to each other. I can say y equals y, which means in this case, negative x plus 4 on the left equals 2x plus 1 on the right. Add x to both sides. We'll get 4 equals 3x plus 1 minus 1 on both sides. My time's almost up here. equals 3x over 3 on both sides. And I'll get x equals 3. So now on my clock, I'm sorry, x equals 1, I've got 20 seconds left, so I'm only going to do one of them, and that's going to be the easier one. So if x equals 1, I'm going to say 2 times 1 plus 2y equals 8. That means 2 plus 2y equals 8. Subtract 2 from both sides, 2y equals 6, and then I'll get y equals 3.